Here's one of the more counterintuitive aspects of cancer biology that researchers have discovered in recent decades. Your immune system, which is supposed to protect you from disease, can sometimes actually contribute to cancer development. This isn't because the immune system is bad or malfunctioning in the traditional sense. It's more that cancer cells have learned to exploit and manipulate immune responses for their own benefit, and chronic sun damage creates exactly the conditions where this can happen. Under normal circumstances, your immune system is one of your best defenses against cancer. Immune cells patrol your tissues, identify abnormal cells, and eliminate them before they can cause problems. This happens constantly, and most of us never develop cancer partly because our immune system is so good at catching problems early. But here's where things get complicated. When inflammation becomes chronic, as it does with repeated sun exposure, the immune system's behavior changes in subtle but important ways. Chronic inflammation means immune cells are constantly present in your skin tissue, releasing signaling molecules called cytokines and chemokines. Some of these molecules are supposed to promote healing and tissue repair. They stimulate blood vessel growth so nutrients can reach damaged areas. They encourage cell division to replace damaged tissue. They suppress certain types of immune responses that might interfere with healing. All of this makes sense in the context of recovering from an injury. The problem is that precancerous cells can take advantage of these same signals. Let's think about blood vessel growth. Your immune system promotes this to help healing, but cancer cells need blood vessels too. They need oxygen and nutrients to survive and grow. When immune cells are constantly signaling for blood vessel formation because of chronic inflammation, they're inadvertently providing resources that allow abnormal cells to thrive. It's like the immune system is preparing a growth environment that cancer cells can exploit. Similarly, some inflammatory signals suppress parts of the immune system that would normally identify and kill abnormal cells. This suppression is meant to prevent excessive immune reactions during healing, but it creates windows of opportunity where damaged cells can survive when they should have been eliminated. Cancer cells that arise in this environment have a better chance of going undetected. There's also evidence that certain immune cells in chronically inflamed tissue can release factors that directly promote cell survival and growth. They're trying to help healthy cells recover, but damaged cells with cancer-causing mutations receive the same survival signals. It's like sending a "stay alive and multiply" message to every cell in the area without being able to distinguish between healthy cells and dangerous ones. What's particularly insidious about this is that it creates a feedback loop. The immune response that's supposed to help actually supports abnormal cell survival, which leads to more tissue stress, which triggers more immune activity, which further supports abnormal cells. Breaking this cycle becomes increasingly difficult as it progresses. The takeaway here isn't that your immune system is bad or that you should suppress it. The immune system remains crucial for cancer prevention. The real lesson is that keeping your immune system in its normal surveillance mode, rather than constantly activated in an inflammatory mode, is what provides the best protection. And the way to do that in the context of skin cancer is to prevent the repeated UV damage that keeps inflammation chronically active. When your immune system isn't constantly responding to sun damage, it can focus on its primary job of identifying and eliminating abnormal cells before they become dangerous.